All right. So I wanted to go over writing formulas and writing names. I'm doing this during dismissal. My kids are all gone, and so you're going to hear the announcements. So I apologize for that, but I don't, I just want to get it done so I can upload it. All right. And you may hear some background noise. My computer is right beside the projector, so that's probably what you hear. All right. So, first thing you need to remember is that if it's a metal and a non-metal, then it's an ionic bond, and you need to follow the rules for ionic compounds. If it's a non-metal and another non-metal, then it is molecular, also known as covalent. Molecular refers to the fact that it's made of molecules. Covalent is the bond, the type of bond that holds the compound together. All right? So we have ionic and covalent bonds. The other thing you need to have in your head, like you need to know this, is on the periodic table, everything in group 1 is 1 plus. Everything in group 2 is 2 plus. Everything in group 13 is 3 plus. Everything in group 14 is 4 plus. That doesn't look like a 4, but it is. And then everything in 15 is 3 minus. Everything in 16 is 2 minus. Everything in 17 is 1 minus. And everything in group 18 is 0 because they don't form ions. At least not in any chemistry we're going to do. Right? So we look at sodium, Na. Sodium is in group 1. It is a metal. So it has a +1 charge. Okay? Sulfur is in group 16. So it is a 2 minus charge. And I'm just getting this from looking at the periodic table. I haven't memorized all this. I look at the periodic table. And depending on what group it is, I know what charge it has. Mn is in group 7. So it's a transition element. So we have to use Roman numerals here.
We are still waiting for Julian Cabral out front, please. Please send Julian Cabral out front as
is in group 17, so it's a 1 minus. So it's a 1 minus there. Sodium is still a 1 plus.
Sebastian and Isabel Trejos out front, please. Sebastian and Isabel Trejos out front.
Is in group 14.
Latreia Gray out front. Latreia Gray out front.
I'm going to change that. I'm going to make that a P, and it's a 3 minus. That is a 3.
We need Alicia and Latreia Gray out front. Alicia and Latreia Gray out front.
Manganese, again, is a transition element, so we have to use Roman numerals.
Ashley
we don't
Angelone
know
out front, please.
what
Ashley
the
Angelone
oxidation
out
number
front.
is just yet. Okay? These two, this is a non-metal, this is a non-metal, non-metal, non-metal. So these are covalent.
Covington and Taylor Maddox up front.
These are ionic. So it doesn't matter what, for these down here, for the covalent ones, the charges don't matter because they're going to share electrons. These transfer electrons. These share electrons. All right? So, for writing the formula in an ionic compound, the ion charges have to equal 0. So, since I have a 1 and a -2, they don't add 0 or add up 0, so I have to have 2 sodium. So my formula is Na2S. That's all there is to it. Okay. Now this one with manganese, we can't do it without knowing the name. So let's say the name is...
All right, teachers, all cards have now been called. If you have any students remaining, please send them to after school. If they don't normally go to after school, please remember to call their parents and then check them into after school. Have a great day.
All right. So manganese bromide and manganese bromide, right? Manganese can have more than one charge, so we have to tell people which charge it is in the name. Okay? So if we look at that and it's manganese 3, we know that this manganese is a 3+. So that means I need 3 bromines to balance it out. So that's going to be MnBr3. If we look at sodium and bromine, bromine is 1- and sodium is 1+. They already add up to 0. So it's just going to be MnAbr. Here, manganese is a +2. Remember, it's a transition element. It can have more than one charge. So we're going to... So 2 and 3 aren't easy. So we have to find the lowest multiple of 2 and 3, which is 6. So the only way to get 6+ is to have 3 manganese. So I'm going to have Mn3, because 3 times 2 is 6. And then I need 2 phosphides, or phosphorus, because 2 times -3 is -6. 6 minus 6 is 0. All right. So let's finish off the ionic compounds here. So with ionic compounds, you just write the metal first. Sodium, okay? And then you change the N of the nonmetal to I. So it'd be sodium sulfide. And then for sodium bromide, it'd be the same thing. We just write the name, sodium, and then bromide. Okay? Now for the covalent compounds, or molecular compounds, we have to use prefixes. So we have to know the name, or we have to know the formula, one or the other. Okay? So let's say, and I am just making stuff up right now. Okay? Let's say it's like disulfur triphosphide. Okay? The prefix shows us how many we should have. Disulfur, that means it's Si2. Tri means 3, so triphosphide, P3. All right. Let's
Good
say...
afternoon. Can the Keith Bay family please come to the front office? Keith Bay family, come to the front office, please. Thank you.
All right. And again, for these molecular ones, I'm just making up numbers to give you an example. All right. So we got Si. Now that's the first element, so we don't have to put a prefix. The prefix for one is mono, but we don't have to put it because it's the first one. All right. So we're just going to write silicon. And then bromine becomes bromide. But there's more than one. There's 2. So we have to put a di in front of it. So it's silicon dioxide. All right? And that's it. Now the homework or the classwork assignment was like this. And I think partly it confused people because everything is completely made up. Like absolutely completely made up. But you would do it the same way, okay, because these are the rules, all right? If it's in group 2, it's 2+. If it's in group 11, it's a transition element, and you have to use Roman numerals. If it's in group 16, it's a 2 minus, right? So that's how we do it. Shoot, where's my cursor? There it is. All right. So these are the answers. It's a little messy. But if it's in group 2, then you know that it's a 2 plus. If it's in group 11, we know it's a transition element. 16 is a 2 minus, 17 is a 1 minus, and group 15 is a 3 minus. It doesn't matter if it's a made-up element or not. Once you know it's in group 17 or 2 or whatever, you know the charge. If it's in groups 3 through 12, you know it's a transition element. All right? We know as soon as we see that we have a metal and a nonmetal, it's ionic. As soon as we see a nonmetal and a nonmetal, it's a covalent. And I told you whether they were metals or nonmetals. All right? So EM and PM had a 1 plus and a 1 minus. So your formula is just EM-PM. And your name is Emertonium punch type. All right? VE and SP. VE is in group 11. It's transition. We don't know what the charge is. So we have to look at the charge of Spekine. Spekine is a 1 minus, but I have 3 of them. So that means this part adds up to 3 minus, which means this part has to equal 3 plus. And since there's only 1 atom, that means that 1 atom has a charge of 3 plus. All right? And then we have Emertonium and Spekine. All right. Emertonium is a 2 plus ion. Spekine is a 1 minus ion. So I need 1 Emertonium and I need 2 Spekine. So EmSp2 is the formula you're looking for. All right, VE and PN, again, we look at the name and it tells me that this atom of Velcronium has a charge of 1. Okay, so that's a plus 1. PN, punchtine, is in group 16, so it is a 2 minus. So I need 2 Velcronium atoms to balance out the 1 punchtine. Right? Now down here again we have a nonmetal, 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 nonmetal. So these are covalent. Okay? So that means they share. So we look at the formula. This 2 becomes di. This 4 becomes tetra. Right? Going the other way, tri becomes 3 and di becomes 2. And notice that the ending for each one is "-ide, 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 "-ide". The only ones that end in "-ate" or "-ite" are going to be the polyatomic ions. So I hope this helps, and I'll see you in class.